Welcome back everyone, and in today's video we're going to do something more fun. We're going to get away from all those systems like deferred lighting and all that stuff. We're going to do some fun. We're going to actually make something not too complicated, but fun. I have on the screen right now is something called the Spiral Core from an anime called Gurren Lagann, and it's one of my favorite animes. And I was actually going to model the core in a Blender and kind of start using it as a prototype thing for special effects and shaders. So I have my own little model I can use because I thought that'd be a fun shape because it has a lot of cool little small details. So I decided as a personal challenge, instead of modeling it, can I programmatically create it? Can I make it a procedurally generated mesh? And this is what the video is about. How to make that shape, the drill, the base, the handle, the whole all of that in procedurally generated using nothing but predefined vertices and applying a bunch of math to it. So let's get right to it. So I'm going to whiteboard it a little bit first. So the first thing we're going to deal with is we need to make the drill. That's like the most important aspect of the spiral core. And to make the drill, it took me a while to come up with it, and I kind of went and researched how to 3D model it easily. And then when I saw the process of 3D modeling, I thought, you know what, I can actually probably program all of these steps and do it all in JavaScript. So I don't know if this is the best approach of doing wrapping of things around cylinders. The steps were. Let me take a step back. The steps were you make your flat plane, then you wrap it around the sphere using a modifier, and then you taper it, and the end. So technically in Blender, it probably take you like 5 minutes to do. So I probably spent like a day and a half programmatically doing this, but it worked out pretty well. So like I said, now going back to what I was originally saying, that I don't know if this is the best approach of wrapping a plane around a cylinder, but the approach I came up with actually works pretty well. So the main idea, really, let's say I have a couple of points. I have one point here, and I cheated. I made sure I put my points in certain places to make it easier to wrap around. So let's say it's uneven, because it's always important to test things sometimes with unevenness, right? So let's say this is my plane. I'm looking at from the Y view, whatever, like from the top view, and I'm looking down. So this is my plane. These are my points. I have them spread out this way, and I need them to wrap around, let's say, a cylinder. In this case, just a circle for now. So if I put them, let's say the plane in the center of world space, and everything's spaced out like there's uneven points. So this way the center point is at 0, makes things a lot easier to do. I think in just to demonstrate it. But you probably my approach probably will work either way, as long as you have the entire object centered from origin. So if this is 0, right? We can pretend that should be at 0 degrees. So all the points over here count one way. All the points over here count other way. So we're going to basically build everything like this in this direction. It's going to go from the center out. Technically, programmatically, I'm going to take the center, calculate the end offset, and then build it this way. From like let's say since it's a 0, this will be the -1, and this will be 1. So we're going to build it like that programmatically, but ideally, technically, the way I'm building it is from the center out, from the most center point to the most outer points. And it helps if it's even, like the last point on both ends. So this way they wrap around at the exact same point. But it wouldn't really matter. You just have to make sure your math is about right. So if this point is -1 at the furthest end, and this one is 0.1 at the furthest end, that makes it easy to kind of connect the dots sometimes. So let's say that we're looking at the sphere, the cylinder from the top. Let's say we make this point the starting point. So and it's like the bottom center. So what we can do is then cut the cylinder in half. and going this way is about 180 degrees. Or, since we do everything in radians, pi. I don't know if it's catching, we're starting to see where I'm going here. So if I draw this point on this point of the cylinder at 0 degrees, when I go to this point, let's say this is like at 0.8, and this one at negative 0.8, and this is 0.8 positive. When I want to calculate the next position, I just say 180 degrees times like negative 8 or 0.8. Let me undo that. So whatever degrees that is will tell me what degrees it is. So I can take that point, multiply get the degrees, and then I can use that with cosine and sine, and then multiply it by a radius, and it'll actually give me this point, because you also have to know the radius from the center. So if I know the degrees and I know the radius, then I know the point goes here. And at the ends, both are 1, so 1 times 180 degrees is going to be this point. So both ends will end up connecting to there. So ideally, this flat plane will actually wrap around the cylinder this way. You know, it's from this to the center, from second to last, and then you can kind of connect the dots and you make a circle, and it's a sphere. Now let's say if I make this point, let's say stick out further out. So let's say this doesn't exist anymore. So it's kind of like this shape. Everything still works, but if let's say if I know the radius is like 5, and then the difference, like if at here the radius it would be at 0 a z position. So if the z position is, let's say 0.1 or something, or let's just say it's 1 away, I can just take the radius plus whatever this is. And if this is in a negative zone, it'll be 5 minus 1, and it'll be 4. So the point, instead of the point being here, it'll be here. And the point will be here. So ideally, when you end up writing the sphere, you end up doing it here, and then I guess like it'll end up making this weird shape. Depending on how many points you have and how everything is laid out. So that is the gist of how I wrapped a plane around a cylinder. Let's see. And the last thing to make, so once I have the cylinder and my patterns wrapped around the cylinder, the last point I need to do is, so let's say this is our cylinder, but now I need to taper it. So I have like, let's say I have my spiral pattern on my cylinder. Because that's what we're going to do. We're going to make a spiral pattern, but it's going to be flat 2D, and then we're going to wrap it. So now we're going to have this pattern. Now it's perfectly still. Now we need to taper it into a drill. Same approach for tapering. Tapering is when you make one side or both sides or whatever, kind of into basically like a drill shape. We're going to try to turn this into this. So when I mean tapering, is this part, the top part is tapered. So we're going to keep our pattern of the drill, but we're going to squish the top and the bottom. And, you know, these are all points. So you have like tons of these vertices all over the place. So how do you taper everything, right? And like I said, same idea as how I end up wrapping it. So I defined the most highest Y point as 0. And I defined the lowest point, like the base, as 1. And this makes things easier. So let's say this the cylinder has a radius of 5. When I'm calculating, so based on using the Y position, I can then scale the X and Z positions. So based on Y, I scale the X and Z. So if I'm at the topmost point, my scale value for X and Z will be 0. So if I say X times 0, and z times 0, they equal 0. So that means all these points will be shoved right to the center, right here. Everything will go straight to center. The further away I get from the top point, 0.1, 0.5, and down to the 0.1. So once I'm at 1 as a whole number, when I multiply x and z by 1, that means they stay where they are. So everything from the top gets shoved to the 0, everything at the bottom gets shoved to 1, and then you interpolate or lerp basically that value based on the z value. So that's how I built the drill. So we first wrap everything around the cylinder by, like I say, converting the range of the vertices to a -1 to 1 position. And then we taper everything by the y position by defining the y between 0 and 1, and then scaling the x and z positions so they become more centralized. So this way, what we scale is the distance from the center, so the radius. So the radius gets smaller and smaller the further up you go. And you can just realize you can taper any way you want. There's so many ways you can taper. The idea of tapering. So like you can just create a range, like say -1, 0. Let's just say whatever. Let's say 0, 1, 0. You can end up making this shape really. If you have like some type of sawtooth wave, you can do that. And you can do some really funky things too. You got to remember you have you can, when you do these kind of values between -1 to 1, 0 to 1, you can transform those. You can throw them into curves. So this way you can, instead of being like more of a linear thing, let's say you do a sine wave. So when the interpolation ends up being more curved instead of being more straight. So maybe you end up making more of an oval-ish shape. So yeah, you can really play around with this idea of how I approach tapering and wrapping. Like I said, since I map everything to a 1, it's like -1 to 1 or 0 to 1, and just use those numbers creative. Like that's why I said when I use the values from 0 to 1, that 0 value I can use that to multiply, and that 0 kind of just crushes everything into the center. Gets rid of all radius. So it's a nice fun way. Now, one quick approach I should say that since I'm programmatically doing this, I am you have tons of vertices that are being wasted, especially at the top center. There's a bunch of vertices that are kind of connected together. So you have a lot of duplicate vertices existing in practically almost the same space. In tools like Blender, you can say, get rid of duplicates. But sometimes you need those duplicates if you're going to do UV. So it's a kind of a hit or miss there. So that's all the theory. Now we can start actually looking at some of the code. Simple page, nothing much to do. So we're going to do the wrap test. This is like basically where I started. Just a quick prototype of how it all works. So I just laid out a bunch of points. And that's about it. Those points go into my geometry object that we built over time for fungi. So if you're like a long-time follower, you know what Geo does, the geometry class. It's an array of vertices. That's all it is, and it has functions where it can just compiles it kind of just dumps all the data into just large float32 arrays. So it's nothing magical about the Geo. Like I said, it just has some extra functions in there that helps us to like extrude, which just duplicates vertices and then moves them for us. So simple function. So if you're new to the video, new to the series, if you're worried what the hell geometry is, it's something we built on the series. So it's like if you go back, I don't know at what point I started. I actually rebuilt this thing like probably 3 times. So when you're building a game engine, you just rebuild until you build something that's really useful and modular and reusable and built the way where you need it. So, all right. So we're going to use the geometry class to help us put this together, just make life easier. So here's a bunch of points, and that's really all we need. So if I go here, these are the points. These are the points I drew, basically. But nice, everything's nice and even. It's the green dots. Hopefully you can tell. So I do an offset because I want the center to be at 0, and then I want to go left and right. So since everything, I don't know, keeps going back there, because 0 degrees doesn't appear here in the center. I think it's over here somewhere. So I want to like start here as 0 and then go around 180, and I want to go around 180. So I had to build an offset. So when instead of 0 degrees being in this direction, 0 degrees would be here. So that's what the offset is. It's just to make life easier for me mathematically. I don't need the offset really, because I can start here and draw it this way, and then draw it this way. So the offset is really not needed. I just wanted to be visually. I just want to programmatically do it how I visually see it, or how I drew it on a piece of paper, just to make sure everything is working the way I intended to. So ideally, you don't really need this. You don't. You just do it from the left view instead of doing it from the front view. You know, I could have made my life easier and just move the camera to the right side and just look at it from that direction. But whatever. I don't feel like messing with the camera. I'll just move things around. So you don't really need it. It's just there, just so I can use the front camera. And this is the math. That's all it is. I go through every single vertex. Up here I have the max value, so I know the maximum x value is 2. So I take the x position divided by the max, which gives me a value between it should give me a value. Yeah, it should give me a value between 0 and 1. And since there's a negative position, it can become negative or positive. I just flip it because it builds it in the wrong direction because of how the coordinate system works, and probably because of the offset. So I just got to flip it. So if it's negative, I got to go in a positive direction. If it's positive, I got to go in a negative direction. And then pi. Pi is 180 degrees. Then I take the z position, and I add the radius to it. So like I said, if the z position is different, so if the z is at 0, so it's just going to be 5, 0.5. And if it's any other z value, it just gets added or subtracted to it. And then we just calculate the position of the x and z. This is the same equation you would do in 2D, so it would be the x, y, but in our case it would be 2x and z. And we multiply by length, which is the actual length, z plus radius. And with this all in place, this flat lane now is wrapped around the cylinder. Done. And to demonstrate the idea that the z position works, I'm going to change the z position for some of these. So if I uncomment this, go back here, refresh. Now you can see the 2 points are kind of off a little bit because they're in a different z position than everyone else. And then I do the wrapping. Refresh. And those are the points. They're, instead of being more out, they're in because they're in a negative zone, so they're pushed in. So you get this weird shape when you draw. So I didn't illustrate it very well when I was actually drawing it, but here's the little shape when you kind of move things around a little bit. So you got that shape. Instead of a circle, you got something else. And when I got this to this point, I was like, this is going to work. I can actually programmatically make the spiral core. So the next step is, now that you've got all this prototyping working, that I can actually, this is going to work. Now I'm actually going to go try to build the actual shape for the drill. So instead of so this time I decide to try more of a complex shape. This is I want a plane, and I want these points wrap around. So like I said, I made this shape more complicated, more detailed. So, and essentially I built it as a row. So each one is actually a row. This is one row, that's a different row, that's another row, and that's another row. So this way I can kind of connect all these as if they were a grid. So these are just not randomly placed. They are placed as a grid, but the Z position is different. So like I said, it makes it easier to triangulate. So in all the code I've had to triangulate like grids for terrains, I can then use it for here. We can use triangle strips, and we can just use just regular quad triangulation. So yeah, so we got that complicated shape. So that's how it's defined. Like I said, I just treat it as a grid, and I just lerp the Y, or not the Z position. Yeah, this is the Y position. This is X. This is how I calculate X. This is how I calculate Y, and this is Z. Everyone shares the same Z. And I have an array, and the idea of this definition array is that the first point is where the first Y is, and this is where the second Y is. So from this point to this point, what is the Y position? So I lerp the Y position. So when I'm here, this has a, let's say, a 0.9 position, and then the end has a 0.2 position. So here and here, and then I just lerp my positions from there. So that's how I end up calculating that kind of curve. I define the A, I define B, and I lerp the Y position from A to B. And there's the second row, and that's the final row. So that's how that's defined. So I defined basically those starting and ending positions, and then I create diversities based on that. So it actually was a simple algorithm kind of to build this. Now, taking the exact same math equation, like I really didn't change anything, and there you go. We got some wrapping, and we're like, well, how can I tell if it's wrapping? Well, if I do this to true, I make this into a low poly, and I don't define this as a point. I want to define it as triangles, and I want to not call faces because I want to see the backside. And well, you can't tell because everything's triangulated perfectly. All right. So let's see. All right. So we'll go back to here. So we can't really see it yet, but if you look carefully, you can tell that here's the start, and then it starts to slowly spiral down to where my mouse is, making sure my face isn't covering the mouse. So there it is. So I made the shape more complicated. So now we move on to the actual drill part. I was like, you know what? At this point in the game, I'm like excited. I'm like jumping for joy. Because like I said, I didn't have a tutorial to teach me how to do this. This is me, after a year and a half of doing this work, actually starting coming up with my own ideas and my own concepts, a little bit on my own. So taking that idea where I'm defining the start and end position of each row, now I defined all the little bits and pieces, and then I actually change the Z position on certain parts. So I made this shape even more complicated. And it's hard to tell what shape it is. But at this point, I can show you because I am triangulating it. So I do, like I said, I'm just triangulating a grid. And let's see. I think this is true. Make this into low poly. Make that and that. And if I refresh, there you go. So now this is the shape I'm generating. But like I said, it's still a row. I'm going down this point, going this way, this way, this way. Everything's still a grid. I'm just changing the Z position and changing the Y position. So it's kind of got that groove thing going. So now I have like this nice flat plane with the groove built into it. It's a nice three-dimensional shape. Now all I got to do is run it through the exact same equation that I had before. Like I said, the same algorithm of wrapping around the cylinder. Same thing. And voila. Now we have... Now, the only difference is, you probably can't tell here, but over here, there's a gap. So I didn't feel like fighting to get this gap. Like, this to me was just a challenge to see, can I do this programmatically? And in the end, I am still going to go to Blender and model this because I want to do UV mapping and a bunch of other things. It's just easier to use a tool than to generate all that programmatically. But I wanted to see, how far can I go and build the shape? So here you go. There's the shape. So now the last step is to taper it. And like I said, the tapering is all based on the same concept, but now using the Y position and then crushing or scaling the radius at each level of the Y. And tapering the cylinder is right here. And the maximum Y is 1. And like I said, I just do the same thing. I get the vertice, I calculate the scale. So whatever the scale is, I invert it. This gives me the angle based on the X and Y. Or if it's in 2D world, it'll be an X and Y position. But it's X and Z. I get the degrees and radians. I get the length. And then based on my scale, I scale the length and multiply it by the cosine and sine of the angle. And then just replace it. And that will then automatically taper. And ta-da! I have a spiral drill. And it spirals really well all the way across. So we wrapped a flat plane that has some, basically a grid. We have a grid plane, and we wrapped it around the cylinder, and then we tapered the cylinder. And now we have a drill shape. And you can. I'm really curious what kind of things else you can do by using these two very simple algorithms. So that's our drill. For funds, I decided to add some extra things to it. So I would like to go back to this. That's okay. I don't need the call face. Refresh. Here you go. You can see what the spiral looks like when it's not triangulated. Let's see. So I decided, well, since I have the drill, I want to make a platform just for fun. And this is going to be very simple. So I define a bunch of different points in 3D space. I just hand jammed it, as someone I know would call it. And I probably have to state this to false because I don't have any triangulation. Refresh. There you go. So probably hard to tell what the hell I'm doing. It's just basically just these weird points in space, right? So I got these random weird points in space. And when I was creating King Kite's planet, that's when I started doing procedurally generated meshes and actually created a planet. So if you're really interested in building a tree and houses and a planet with a road on it, King Kai's planet, again, another anime like Dragon Ball Z, using our lathe function. The function is practically the same. I just probably tweaked it up since it's probably been a year. And I think I created a new function called triangulate. No, actually, no, it's about the same thing. I just renamed it. Triangulate the lathes. So whatever this creates, this function makes it easier to triangulate. And a lathe is a tool that you use for woodworking, essentially. And idea is you kind of just wrap it. You just take these points and you duplicate it and you wrap it around in a circular fashion. So if I go back to low poly, true, because I want to use the index, and I want to see the triangles, and I don't care about culling. So this point, if it wrapped around in a circle, ta-da, creates this. It's a platform, and there's nothing at the bottom because I didn't draw the bottom face. I just drew the top face. There you go. And like I said, that was pretty easy. You just lay out a 2D thing, and you just wrap it around in a circular fashion, and then you triangulate it. Again, this is stuff we've done. I did this creating the road for King Kai's planet. This is the same idea, but the same practical code, but now I'm using it to do other things, not just build a road around a planet. So that's the platform. And the last thing to look at is the hook. And the hook, I'm not going to step too much through it, but same thing with I do with King Kai's planet. I did extrude. It's just basically I defined a specific shape into a 2D shape, and then I just used the function and I extruded 3 times and scaled it. So I did like a bunch of scaling and extruding and repositioning. That's very simple. Like I said, this is stuff that we did for King Kai's planet. I don't want to do that yet. And I'll switch over to hook. And refresh. And there we go. And there's the hook. It's this part. And all the screwing and everything else end up creating it like really perfect. Like I loved how it just simply turned out. Just it's not it's got this weird extra thing in the curve here that shouldn't really be there. But that's fine. It's the way I scaled everything. But overall, the entire shape is like perfect to me. Whoa. So now I got the hook, and I created a platform. I created the drill, and I also created the middle piece too, using the lathe function too. But I didn't bother showing it here. So one last thing I created for fun, I created a new file called animations, and I threw it in the lib folder. Very simple. I have something called spin animation, and what it does is you pass in O object. I really should say T or transform. So you basically pass in a transform object, like a renderable. Give it a speed and pass in like the initial quaternion, like this. It's an initial rotation, just in case you want to start from a certain rotation and then kind of just spin it based on that rotation. So what this function does is that it returns back a function. This is a function. This is a shorthand function. So it creates a function in real time for you, and it saves the reference to the transform or the renderable, the speed, and whatever, and uses a sawtooth wave and everything else to calculate a new rotation based on the Y position. So it just rotates, and like I said, it takes this and just rotates that quaternion. And if you don't pass in a quaternion, it just creates a blank quaternion which points forward. So and there you go. And like I said, it goes based on speed, and it goes between 0 and pi 2, which is 360 degrees. So it goes between 0 and 360 degrees, and it's just a continuous circle. So I can just pass in a function. Like I said, pass in something and instantly get a function. Like with it does, instead of building a class and everything else, I saw this in something else, and I thought this is a great way to kind of build a very simple thing that I can reuse. So I have my final version. So this is so you can see how it all works. So this is the final version. I have my drill. I actually just used my cylinder class to create the drill base. I got my hook. I scaled it. I positioned it. I have my platform. Then I created a transform that I put all 3 pieces of the drill together. So basically, it's an assembly if you're using Unity, I think. So like I said, here's my spin animation. I pass in my spiral core because I want to rotate everything at the same time. Give it the speed and add it to the scene. And that function, did I dump it? It should be at the very top, maybe. Yeah. So that spin animation is just the function. Like I said, I just have to call it. Done. And it does the animation for me. So if I go here and I go to core, and here we are. And this is the spiral core. And it's spinning. You know, I just color it, I put the platform in, and then has that new little spin animation. And the end. This is I want to use curse words, but then I get flagged every time I use a curse word for some reason. But this is amazing to me. I love this. Like the idea that I was spent like months thinking about modeling this in Blender, and to just one day saying, can I do this programmatically? And to just realize that I'm at this point in my life where things like this is possible by doing it purely in math and by writing algorithms. Like I don't even like I was able to actually implement this scene completely in code, and you've seen all the code, and I showed you the progress of how I built the core. So once I build the drill piece, everything else is easy because it follows all the simple things that we've done in the past for King Kai's planet. So here you go, spiral core. Let's end it like that. Oop, the point is done. Yeah, that's it. Hopefully you learned some cool things. Like I said, the whole idea of wrapping around a cylinder is a fun kind of concept. Like I had fun figuring that piece out and getting it to work, and it ends up being very simple. I don't know if there's better, smarter ways of doing it, but what I have is actually quite simple itself, and it's, I'm sure you can probably apply it easily. Like I said, this only works for planes, so it's really just wrapping a flat plane around a cylinder. And as you can see, you can kind of cut in grooves and like patterns into your plane by moving things around, and then it just wraps it around. So yeah, and tapering is super easy. So yeah, just have fun with it. Hopefully, I would love to see anything you do with it. Like I'm just curious what else you can do. Like I built that stuff was purpose built just to build that drill piece. I'm just really curious what what anyone else can do by wrapping around a plane and do some really cool fun things. The grooves can be the other way around, where you actually make it look like a screw piece. So you can do a lot more things. It doesn't have to look like that. It's like just create the pattern that's flat and just wrap it around, and just make sure you can triangulate it. If you build everything kind of as a grid, then all my code should work just for you. Just everything is kind of just aligned together, as long as it's built built as a grid. And all you do is just shift things in the right place where the triangles don't overlap. A lot to take care of, a lot to consider when you're doing this mathematically. So yeah, let's end it here. I probably made it too long. Please like and subscribe. It helps with the channel. Thank you again for all my patrons. I think I might have another one who joined in recently. Thank you very much. Since I'm currently unemployed, every little bit helps. So if you know someone who's looking for this wannabe graphics programmer who's really willing to learn, I'm available. I'm available. Yay! Yeah. All right. So yeah, I'll end it here again. Bye-bye. See you guys in the next video, which is going to be about infinite terrains. Yeah. More procedure-generated stuff, because why not? Let's have some fun. I got sick and tired of deferred lighting and deferred shading. I want to do some fun stuff. All right. See ya.